Dear students, let us continue with the first video. And in this video, we'll discuss mainly about the zeta potential and structure of the nanoparticles. Okay, how zeta potential and structure of the nanoparticles be estimated in brief, as well as we'll discuss about the loading capacity of the drug, loading capacity of the nanoparticles for the drug. Okay, and which we usually call it as encapsulation efficiency. And we'll also try to discuss or try to complete the in vitro drug release studies for the nanoparticles. In vitro drug release studies for the nanoparticles. Okay, so coming to zeta potential, you know already about what is zeta potential. Okay, zeta potential is the potential difference between the shear plane and electrically neutral region surrounding a particle in a suspension or in a colloidal dispersion. Okay, and this is very much concerned by the pharmacist, because this causes it affects the stability of the dispersions, both both the suspensions, colloidal dispersions, which includes nanoparticle dispersions also. Okay, now I told you what is zeta potential. Okay, and what the zeta potential indicates. Zeta potential indicates the extent of surface charge, the extent of charge carried by the surface of the particles. Here, since we are discussing about nanoparticles, okay, the extent of surface charge carried by the nanoparticles. This zeta potential imparts colloidal stability due to particle-particle repulsions in a dispersion. Okay, zeta potential measurement also helps in designing the particles with reduced reticuloendothelial uptake. Okay, for the purpose of drug delivery, often we may need to divert the nanoparticles from reticuloendothelial system after after the nanoparticular injection was made into the system circulation by intravenous route directly. Okay, so since affects the zeta potential affects the uptake of nanoparticles by reticuloendothelial system, by adjusting the zeta potential we can able to increase or decrease or avoid the uptake of the nanoparticles by the reticuloendothelial system. Okay, you already know that reticuloendothelial system is a part of lymphatic system present in our body. Okay, and often we will target the various types of drugs using liposomes, neosomes, nanoparticles, etc. To the various components of the reticuloendothelial system. Okay, and an important finding in the literature, that is Seichmann, a scientist, in the year 1995 incubated freshly prepared lecithin stabilized tripalmitate lipospheres with poloxamer 407 and poloxamine 908 solution, and confirmed polymer adsorption by measurements of the zeta potential, for which he has used the technique called as laser Doppler anemometry. Zeta potential was considerably reduced from minus 29.6 millivolts to minus 1.9 and minus 2.9 millivolts for fresh liposphere and poloxamer 407 and poloxamine for 908 coated lipospheres. Okay, so this finding and this example says that, okay, we can able to adjust the zeta potential. Okay, we can able to adjust the zeta potential of nano-sized particle drug delivery systems like liposomes and nanoparticles, and how zeta potential affects the okay, and how sorry, and how the and how the components of the dispersion medium affects the, okay, and how the composition of the nanoparticles or liposomes affects their zeta potential in the dispersion system. Okay, I repeat once again. The composition of the particulate system and the components of the surrounding dispersion media both will affect the extent of charge carried by the particulate system. Okay, nothing but the zeta potential of the particulate system, that is nanoparticular dispersion or liposomal dispersion, etc. Okay, so this way zeta potential is very important, is a very important parameter to be estimated or to be adjusted, okay, or to be optimized, okay, for nanoparticulate systems. Next, coming to the structure of nanoparticles. The structure of nanoparticles can be determined by 31p NMR technique. Okay, after complexation of the nanoparticles with Mn2 plus, and Mn2 plus stands for manganese, okay, double plus, and the other methods include labeling of nanoparticle formulations containing phosphatidyl ethanolamine with trinitrobenzene sulfonic acid. And the agent reacts specifically with surface polar phosphate heads on the nanoparticles. There is an optimum ratio of core lipid and phospholipid when surface phosphate groups are maximum. When phospholipid is further increased, there is a decrease in surface phosphate groups, resulting into decrease in 31p NMR resonance peak area. And finally, it has been seen that the other phospholipid structures such as liposomes are formed inside where many polar phosphate groups are concealed inside the concentric bilayers. Okay, so this is a brief about how structure of the nanoparticulate systems mm, be estimated by two commonly used techniques. Okay, and next coming to the drug loading capacity of the nanoparticles. Okay, or determination of incorporated drug in the nanoparticles. Okay, so this parameter is very important to to measure, especially to measure the amount of drug incorporated in the nanoparticles, because it influences the release characteristics of the drug from the nanoparticles. Drug loading capacity also influences the pattern of drug release from the nanoparticles. Okay, the amount of drug encapsulated per unit weight of nanoparticles is determined after separation of free drug and other components from an aqueous medium. This separation can be carried out using various techniques like ultracentrifugation, centrifugation filtration, or gel permeation chromatography. Okay. In centrifugation filtration technique, the filters such as ultra free MC, okay, stands for millipore, or ultra start 10 sartorius are used along with classical centrifugation techniques. Okay, nothing but along with centrifugation, okay, the the filtration technique is also used simultaneously. Okay, something but simultaneously centrifugation and filtration will be subjected onto the samples. The degree of encapsulation can be assessed indirectly by determining the amount of drug remaining in the supernatant after centrifugation filtration or ultracentrifugation of nanoparticle suspensions, or alternatively by dissolution of the sediment in an appropriate solvent and subsequent analysis. Okay, nothing but the amount of drug loaded can be determined by analyzing the amount of drug present in the supernatant obtained after centrifugation or centrifugation filtration, or by dissolving the residue obtained after centrifugation in a suitable solvent. The standard analytical techniques like spectrophotometry, spectrofluorophotometry, okay, column chromatography like HPLC, and liquid scintillation counting can be used to assay the drug, okay, present in the centrifuged sample. Okay, and gel permeation chromatography can also be used for determination of drug loading capacity. When gel permeation chromatography is used, Cephadex or Cepharose gels are used for removal of free drug from the nanoparticle preparations. First, preliminary calibration of column is carried out using nanoparticles as well as free drug. Nanoparticle preparations are applied to the column and eluted with suitable buffer. Fractions containing the nanoparticles can be collected and analyzed for the actual drug content after dissolution or extraction with appropriate solvent. Nothing but in column chromatography like HPLC, the column is first standardized with free with free drug as well as with nanoparticle preparation. Okay, and then sample containing nanoparticles will be injected into the mobile phase, which passes through the columns, and the elute collected is analyzed. Okay, for the presence of drug and the amount of drug, okay, present in it. And finally, apart from all these techniques, the drug content of nanoparticles can also be determined directly by extracting the drug with suitable solvent under optimal conditions and subsequent analysis of the aqueous extract. Okay, dear students, with this I am ending my session, okay, in this video, and let us continue the in vitro drug release studies in our next video. Thank you.